Okay, for today, I want to start with talking about the lab. This is the tennis ball lab, and let's say that you threw the ball up in the air and you got this result. This is your starting height of, let's say it's 1.6 meters. Do you agree that the ball peaked at some peak right there? And then the ball hit the earth right there. Now here's the thing that people don't get. The labels on the X and the Y axis. This is the thing that I try to teach people in my ACT class is you gotta look at the labels because this could be a lot of things. This could be the distance. Don't write this down because it's not gonna be the distance from the thrower. You could track that, okay? But that is not what it typically is. What typically is on the x-axis? Time. Time is typically on the x-axis, and that makes it a completely different graph. Okay, so let's do this as time. Then that makes this a completely different thing. This is not the distance away from the thrower. That's the time when the ball's height was what? 0. So technically, that is the time you're finding in this lab because you're going to throw the ball up and you're going to find out that it landed at, 2.1 seconds. Well, that means that right there is 2.1. How on earth do you go backwards and figure out how high the ball went? All right. Well, first off, we got to know the general formula. Do you remember the general formula for this thing? If you're raising your hand for that, I assume you probably do. Yes, this. Wait a minute. I know you're talking about the quadratic formula, and that's a good thing, but we need to know what we're going to do the quadratic formula on. What is that equation for a parabola for, what is this called? A parabolic motion equation. Hint, negative. There you go, negative 4.9 t squared. Keep going. Oops, excuse me.
I don't remember what the middle thing is.
And the middle thing is velocity. So let's say that you threw this thing at 3 miles per hour. That's the thing you don't know. You don't know your velocity. You don't know how strong you are. Can you throw it at 3 meters per second in the upward direction? I don't know, probably. But what is this number? We won't know. So I'm going to call it VT. Okay. And then last but not least, what's this last thing? It's not a T. The last thing is the height at which you did what? You released the ball. Okay, so you released the ball at 1.6. Is that going to be true for everybody? Of course not. Depends on you. Depends on whether you released it underhand or whether you released it overhand. And it depends on a lot of things. So you'll get the video and you'll figure out what's right height for you. Okay. And now, what do we know? After you've done the lab, you've thrown the ball up, it took 2.1 seconds? We do know that, don't we? All right. We don't know the velocity. We do know something else. I'm not going to say it. You have to figure this out. You have to get your brain around it. That's what makes it a lab. If I just tell you what to do, then this is super simple and we're done. Okay, so you have to figure out how to figure out. You'll be able to figure out a lot of things. You'll figure out how fast you were throwing it. You can also figure out how long the ball, no wait, we know that, how long the ball was in there. That's the thing we start with. How high the ball went. All right, last thought. There's a few formulas I'd want you to remember. Who remembers the formula for finding the vertex? This is one of the formulas that smart kids don't remember. And it's on the ACT. I'm just curious. This is just a show of hands to show I think I know that formula. Raise your hand if you think you know that formula. Awesome, that's half the room, but in a really smart class. Okay. So how about this? Who thinks they know the formula for that when the ball hit the ground? And how about if I said this? Isn't that the root? Isn't that the x-intercept? Isn't that the 0? There's 4 names for that spot. It's just an upside down parabola. Snap out of it. You can do this. It's an upside down parabola. How do you find those spots? Well, maybe you've never had a teacher call it the quadratic formula before. Isn't the quadratic formula The quadratic formula, because it finds the roots, which is that spot. Now, a lot of you guys were thinking of that when I said the vertex. That would not have told you the vertex. The quadratic formula would not have told you that. The quadratic formula tells you this one. What tells you that top one now? Who thinks they remember the top one is the vertex formula. It'll be less people than last time. Okay, now we're down to about 8 people. Think they remember that formula. All right, who's pretty confident? Back, sir. And what you are correct, but I need to know what is equal to that. Negative b over 2a. The beginning of a formula is always very important. X equals. Very good. Notice it's the beginning and the end of the quadratic formula. X equals negative b. Blah, 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 blah. It cuts out the middle part. Why does it cut out the middle part? Interesting. Because that part must be 0. Let's think about that for a second. Do you get what I'm saying? If that part is 0, then this is what's true, right? What would make that part 0? Would have to be a perfect mix of B and A and C all working together to make that part 0. How about this? If this is truly the vertex formula, do we want 2 answers for it? No. So do we want it? We don't want plus and minus something. We want plus and minus 0, because that's the only thing you could add and subtract that would make it. So that brings up this topic. What's that thing called? It's not called the vertex. Discriminant. Very good. The discriminant is where b squared minus 4ac can be 3 things. It can be positive, it can be negative, or it can be 0. If b squared minus 4ac is positive, then you have 2 answers. 2 roots. 2 zeros. You get my point? 2 x-intercepts. And these aren't x-intercepts, so we don't want that. B squared minus 4ac is less than 0, then you've got an imaginary number. Imagine for a moment that's like this. That's like a parabola that goes like this. It doesn't have any roots. Know what I'm talking about? All right, so this has 0 roots. And last but not least, b squared minus 4ac is equal to 0. Means you have 1 root at the vertex. And it's as if, this is going to blow your mind a little bit, we dropped that whole parabola down and made it touch once. Did you get what I just did there? I took the parabola and I shifted it down, and I made it so that its vertex was the 1 root. Okay, so then I can make, I don't want to try to make this more complicated. I was trying to explain why it's negative b over 2a, but if you can just, at this point, if that didn't work for you, deal with that's the formula for the vertex. And it's the part where the plus and minus the square root all disappeared. And this is the quadratic formula. And that's all you need to know to be able to take this equation, which has the velocity right there, which we won't know. We will not know how fast you threw it until we calculate it later. It has your starting height, which is probably going to be 1 point something. Now, nobody's going to throw it from lower than a meter. Okay, and some of you guys are tall enough that it could go over 2 meters. Like you might be at 2 point whatever meters. But from my experience, most people release the ball under about 6 feet. And some of you might be at like 2.1 meters. Depends. This is where it depends on you. Okay, I think that's enough info now that when we go out and throw the balls up later, you'll have all you'd need. And there's just one little key. If I just told you this one thing, I'm so tempted, but I can't because that's the whole point. It's just so easy, and some kid's gonna figure it out, and then they can, there's nothing wrong with helping other people with labs. That's not illegal. You have to write up your own, but you know the time. Then what you're left with then is velocity and the y. But you know more than you think. Okay, so moving on. Let's get to another page. This is where we do some review. Do you remember back in honors higher algebra, you had to graph things like this? Why would you need to graph that again this year? Not because of me necessarily saying graph that. What's more likely is I would say, what is the absolute minimum of this? Wouldn't it be much nicer if it was like a picture and you knew that that spot was at a certain place? You'd know what the absolute minimum was, right? Well, then it'd be nice to know what a picture looked like. You're supposed to know what that picture looks like. What if I told you, if you've forgotten what shape this was and then it's been moved and flipped and all that stuff, if I've forgotten all that stuff, what's the one thing that can always save your butt on graphing? XY chart. You can always make an XY chart and you find, oh, look, the dots are going here. I wonder what's happening. You know what I mean? Like, oh, apparently it's a parabola that's upside down and it's been moved to the right 3. That kind of thing. So get used to not always knowing, but being able to make an XY chart to figure it out. Would you please make a quick sketch of this and figure out where it's, in this case, because it's flipped over, it does not have a local minimum. It's an upside down parabola. So what does it have? It has a local maximum. Does it also have an absolute maximum? Yes. Absolute meaning the highest place that it ever goes. And yes, it has that. I'm going to pause for a second while you check with the kid next to you and see if your parabola generally looks about the same. Pausing. Okay, thank you for playing along, comparing. It makes it more interesting in the long run. And just quietly taking notes by yourself. Okay, if I go to the right 3, that's where everything happens, right? Except it's not just normal parabola that's been moved over there. It is also reflected. And so therefore it should have been something like that. And what was that spot called again? A what? Local maximum and also absolute max. And don't ask me if it can be both. Yes, it can be both. All right. How about, what is this function's minimum? False. Negative infinity, false. It doesn't have one. There's a difference. What's the lowest it goes? Well, when it gets to negative infinity, it's gone to the lowest place. It doesn't ever get to negative infinity, does it? Okay, so the correct answer is kind of one of those dumb, like, yeah, you got me, but it's actually a mathematically wrong answer to say negative infinity. You can approach negative infinity, but you will never get there. Okay, so there is no absolute minimum. You just say no min. No absolute min. All right. So are you saying there's never any minimums ever? Of course not. There can be minimums, but in this case, do we have a local minimum? Yep. Yes. Is that the absolute minimum? No. Is there any absolute minimum? No. Is there any absolute maximum? No. And don't say infinity, because you can't get there. That's a what kind of max? Local max. And when it goes from that local max to that local min, that is called a blank interval. A decreasing interval, you are correct. So this is at -1, 5. And I want to know when it goes from there to here, which is at 3, -2, how do you write that decreasing interval? Take notes on this. This is the kind of stuff There's so many little things like this that you have to know for our tests, and I can't tell you which ones are on the test. All right, the decreasing interval was from here to here is a way to say that. Think about it. Did I just write two y equals lines or two x equals lines? Two x equals lines. I know it's like the y-intercept, but the y-axis, the y-axis is x equals 0. Those are x equals lines. This is x equals -1, and this is x equals 3. Okay, so it goes from -1 to 3. Parentheses, I don't care if you put brackets, it's fine. You either have parentheses or brackets around the -1, comma, 3. Raise your hand if you had that one right. Awesome. Now do the two increasing intervals. This was decreasing. There's two increasing intervals on this one. It's increasing from -infinity until, is a good way to think of it, until it hits -1. Raise your hand if you had that part right. Good. How many of you also remember to put a little u in between the two? Some of you. Okay, and then it goes from, where does it start increasing again? 3 to infinity. There we go. That's increasing and decreasing intervals. Last thing, I'm going to make you one of those Franken functions. Empty spot, filled in spot. Does this pass the vertical line test? Yes, it does. You might have been concerned about this area right here, but since it's empty in one spot and closed on the other, that passes the vertical line test, so this is a function. All right, now here's my question. At y equals 1, 2, 3, 4, at y equals 4, what is the answer? I'm going to say this. F of x equals 4. That's saying y equals 4. And what is the answer? Well, the answer is kind of like, begs the question is, what's x? Because we already know what f of x is. All right. Write down what you think the answer is. And who was high enough level at this early in the morning to catch that there would be two answers? Raise your hand if you noticed that. One person. Okay, so all you got to do is draw a line at y equals 4. Do you get, as soon as you draw that line, you go, wait a minute, it's touching twice. Do you get what I'm saying? F of x equals 4 is really like y equals 4. That is a line. And you draw the line on there and you'll see, ooh, looks like it's hitting twice. Now, I never called that point out because I was on purpose trying to make you not notice it. But that happens all the time. All right, will there ever be a situation where I can draw an x equals line and it'll hit twice? No, because then it wouldn't be a function. Now, could we do that? Yes, but then we just have to say we weren't talking about a function anymore. That does happen on this function. Don't have to write this one. I'm just trying to give an example. A lot of people never knew what a sideways parabola was. I hope by now some of you have caught this. Whereas y equals x squared is a normal parabola. Who caught what this one was? Yes? X equals y squared. Very good. And you remember how we had these rules about what would make things not a function? This is a blast from the past. There's a vertical line test, but there's also solve it for what? Solve it for y, and if you get two answers, it's not a function. You see how this thing is not a function? Touches twice. Okay. Okay. Next, I've got a graph. Even symmetry, supposed to be a parabola, by the way. Even symmetry, odd symmetry, or neither. If it's really a parabola with a vertex at 0, 0, I don't even care how it's been stretched. It's got certain kind of symmetry. What kind of symmetry does it have? It's got even symmetry. You could argue what kind of axis symmetry it has. Symmetry over the what axis? Symmetry over the y-axis is even symmetry. All right. Do you remember this graph? Y equals x to the third. What kind of symmetry does it have? Odd symmetry, also known as origin symmetry. If I take a spot here and I go through to the other side, I drew this pretty badly because I should have hit it by now. I'm going to redraw it because I should be more careful. I'm going to draw it with a family of points. And this spot at 2, 8 goes through the origin, comes out the other side, and ends up at -2, -8. Does that ring a bell? Remember that? Okay, so that's origin symmetry. That's the kind that's odd. Why don't you think we do much with this kind of symmetry? Symmetry over the x-axis. Because they're not functions. Yep. Make sense? Not like that doesn't exist, it's just not a function. Okay. All right, so then that's looking at it in a picture, but how about proving it? So let's say I said I had this equation, and I had graphed it, and it was y equals x to the third plus 2x. And I wanted to know if this thing had odd symmetry, because just graphing it, it's going to be maybe like take a long time to show it. And besides, does graphing it prove that it has odd symmetry? No. Prove that this either does or doesn't have odd symmetry. Hint, first step I'm going to do is change this to an f of x, excuse me, instead of a y, because you're going to stick something into f of x. You're not going to be doing f of x for long. All right, I'm going to pause for a second. Let me give that a try. Just to make sure you're not going too far off the rails, you should have been putting an f of -x. You should have been putting parentheses around where the x's were. That is a big deal. And then once you clean it up, you have f of -x is equal to -x to the third minus 2x. And that right there proves that it's not what? Not even. Because if it was even, the rule is f of -x should come out to f of x. And that right there is not f of x. Okay, so then I'll zoom in a little better here. And now we'll go to doing something important. I'm going to be vague on purpose because I'm going to get a volunteer from the crowd. Who knows what to do next? You, sir. Take out a -1. You mean like drag it outside and beat it up? Yes. Yeah. No. How do you, quote, take out a -1? What's the official word for doing that? Factor out a -1. Very good. Okay. And then I got that -1 out, and then what is left in here? It's really like I divided each thing by -1. If you write Therefore, odd right now. You missed an important step. Who knows what I have to write next? Yes, sir.
Don't you have to make it negative after?
Yep. Negative 1 would be fine. F of x. And really, you just replaced what with what? That
That equation.
with that. Which is what they were. That is f of x. It's defined in the top row. Right there. It says so. So therefore, that's why we can make that swap. And that's the moment you say, therefore, odd. And you've even got it down to a nice, simple, clean proof. It's the thing we try to prove when something's odd. There we go. We've done this for a long time now. So that covers pretty much everything I want to do today. Yes, sir.
If it came out to be even, would we have to do the same thing just without the negative 1?
Once you have proven something is even, you are not required to move on from there. Because if it's even, it can't be odd.
Like, will we have to write the f of negative x equals,
Oh, I got you. Okay, if it had been even. All right. So I will do one in speed mode here to show you what he's talking about. Let's say it said this. And I go, f of negative x is equal to 2 negative x squared. You know what? It won't be long, and you'll be able to do your math this way. Where you'll be able to tell Siri the next step, and it'll just write it. You know what I mean? Maybe you haven't even processed this before, but I know Siri can write stuff, but it can't really write equations well. But wouldn't it be nice if you just to tell it, okay, f of negative x, and it would just write whatever you said, is 2x squared, and then what was that last step you were talking about? F of negative x is f of x. Yes, that's how you prove that it's even. See, because that's that, and they are equal, and that's why that's okay. And final answer, therefore, it's even. No need to go on and prove if it's odd, because it's not, because it's even. Make sense? Is that everything that's on your test? No. We're going to divide it up a little bit. We'll do some more review tomorrow. Today, the rest of the day, is go to Schoology and find the lab folder. Inside the lab folder, you're looking for the tennis ball lab. And since we got somewhat decent weather out there today, you never know if tomorrow is going to rain or whatever. I'm going to go out there today. We're going to throw tennis balls in the air. You're going to have somebody record you. Please be nice. If somebody asks you to record them, say sure. This isn't like groups that have to be working together for a long time. Just work together for today to get yourselves recorded. Okay? Hold on. Yes?
Do you want me to do it once?
Good question. You only have to do it once. If you're one of those people who is trying to set a new world record for how high the ball goes, I'm okay with that. And you can throw it multiple times, but better be recording it if you want it to be real. Know what I mean? I don't want to hear about, I got it to stay up in the air for 4 seconds. Yeah, I'm going to want to see that one. Okay, because that's practically putting the ball in orbit. It's amazing how much higher it has to go to get up for 4 seconds than just 3 seconds. Yes?
Do we have additional homework?
Do you have additional homework? Your homework for today is to start your lab, and that's it. Any other questions? All right, and that's all I have for you for today. If you are at home and you can't do this lab, sure you can. Get a tennis ball, get somebody to video you throwing it up in the air. All you need is when it released from your hand and when it hit the ground. So you need time in the air. Okay, you're gonna go out in the parking lot. Please be aware of other cars driving through. Number 2, do not throw it in the air and have it hit a car. Especially not my car. And if you're working with somebody, you really only need one ball between the two of you. But if you're not sure, grab a ball. It's no big deal. And go ahead, head out there.
I'm putting that kind of ball in the order.
I'm not gonna, I'm